All right, folks, we'll see if this sees the light of day. We're going to look at doing what we did in Excel and Fathom using R just to refresh ourselves. In Fathom, we took a look at some COVID-19 data and some Gapminder data. So we're going to take a look at what this does in R. So the difference here in Fathom, for instance, is that this is all graphical user interface. So what happens is I take a graph down, I say, okay, what does life expectancy look like? I drag, I drop, I hit something, and now I can adjust bins. You know, this is pretty effective and pretty easy. The trick becomes is, when you look at this in 2 to 3 months or a week or whenever, do you remember exactly what you did? And that's one of the challenges when using GUI-based software to look at data is you kind of forget what you did. So the nice thing about R is that it's written in a coding environment. So everything you do, you'll remember because it's written down. So we won't get into the nitty gritty just yet, but just to kind of look at some things. Here we go. We'll look at loading libraries. So this is an important piece of the puzzle. Libraries give us access to different functions. So we can run this code chunk. You can see this here. We'll run this current chunk, and you can see it runs it from the script into the console. Everything is loaded already, so that's perfect. So let's first look at the Ontario COVID cases data. So this is a file that I downloaded. It's located here in my working directory. So in order to read this data into R, I need to do some commands. Now, rather than do commands by typing, this RStudio IDE console allows me to click this and allows me to import the data set. Okay, and so what it does, it's an Excel file. It recognizes it right away. It gives us some examples here. Tells you exactly what it looks like. It opens this library, read Excel. So this is the code preview that we would have. I'm actually going to call this something different, but we can kind of scroll through. We've got a nice little look at what things look like. It's basically the same thing that we saw before, which is perfect. And rather than call it Ontario COVID, which is the file name, okay, you can see Ontario COVID in Excel. Let's call it COVID Ontario. Maybe I'll just call it COVID data, COVID underscore data. It's good practice to use underscores. And so let's import this, and it should work just as so, and hopefully things work out. You can see it showed up here in the console. It ran, which is good. And now in the viewer window up here, I see COVID data. Okay, we also see it here in our environment, and we can see that there are 43,161 observations of 18 variables. Okay, so that's good news. It looks like this. This works similar to Excel. I can sort it any way I want. Let's hit ID here, no problem. And again, we should be all good to go ahead and look at this. So that's kind of how it works. Pretty straightforward. Let's analyze it now. So in order to analyze it, we'll have to insert a code chunk and take a look at it. Okay, so to insert a code chunk, I said we can press Control-Alt-I and we get this code chunk. So this is where we write code to do things. Alternatively, I can delete that and I can just press insert, and we're inserting in our code chunk. So this is fine. So when I start writing COVID data, it knows what to look for, which is good. And then we're going to use this pipe operator in order to say, okay, use COVID data as the input for what I want to look at. Let's kind of look at the first counts of some things here. So again, what I've done here is I've just taken a look at the COVID data. It gives us a sense of what things look like, and maybe we want to see what does the age group category look like, and so we can take a bar plot of this. So let's plot this. So the plot function is called the ggplot. So anytime you're going to make a plot, you're going to use this ggplot. In the ggplot, we map aesthetics to variables. Okay, so again, each individual or observation is a row, and each variable here, case reported date, age group, client gender, etc., are the variables. Okay, and it says we've got all these more rows, those are individuals, and 10 more variables. Okay, and it gives you these variables with class associations. Okay, so we're going to say here x, so we'll put it on the x-axis, x equals age, and as I hit age group shows up. That's perfect. And I want to add if I just hit this on its own, we get nothing here. Well, we get the bottom, but what we don't get is what we're actually showing. In order to do that, we need to add a layer on to R, which is similar. You're sort of setting up your axis first, and then what we want to do is we want to add a bar plot. We're not manipulating the data first. This is just a bar plot situation. So I can go ahead and hit this. Now I have a bar plot, looks as such, and I can see unknown is entirely empty. So again, in Excel, I could go hit, how do we uncheck? We can filter this. In R, we can use a couple commands in order to get rid of the cases that are unknown age group. Okay, and so we'll go through that real quick. So to do that, we're going to filter this, and we can filter it right away. Again, this is something that's handy because you say, oh, well, maybe I wanted to take a look at this. So in R, the command is filter, and we want to filter specifically the age group category. And we want to say not equal. This is a kind of standard Boolean operator. Not equal to, it's a text string, and it was uppercase unknown. So I'm going to write unknown here. And I have to ensure that this argument, so I have the data, I filter anything that's not equal to unknown into the data, and then I do the same graph, and we can see now, as it was before, we have a graph that shows us just less than 20 through 90s, and it gives us a count of each. Okay, so pretty handy. 4 lines of code produces the same graph that took us pivot table, playing around, having some difficulty. We can add some layers onto this, and we'll do that in just a second here with a different type of graph. So this is with no data manipulation at all. Now we can take a look at the data in some different ways and maybe map on a few different things. So we're going to try something here and see if we are able to make it work. And so to take a look at the same sort of plot we wanted to look at before, maybe we want to add an aesthetic here. And this aesthetic is we want to fill up the bars that we would ordinarily see. And those bars here is a fill equals, we want the fill of the bar to equal one of these variables, in this case, the client gender. Now notice as I type this, if I use lowercase c, nothing works. If I use uppercase c, we should be able to make this happen. And I've got one L, so that would, again, that would be an error. Maybe we'll hit this just to see what happens. It doesn't know what it's doing. Unknown aesthetic, FIL. Okay, we've got the same plot. It's not helpful. You'll get an error message. Here's the fill. Okay, this is better. Client gender spelled correctly, hopefully. There we are again. Okay, so again, we've got our plot. We have the bars filled by gender. Again, we look, so we got male and female here, female, male. there's not a whole lot of these other things. So maybe we want to filter it again and say, okay, let's filter only things that are male and female. So to do that, we're going to use the filter, and I want to say filter the client gender category. And this time I'm going to use a command that we'll get used to. It's in. Okay, so it's the % within, and it's going to be in things that are inside the word male or female. Okay, so now it's only going to consider the cases, the rows, the observations that have male or female in them. And again, I want to pipe that to the next level, and we should see a new plot. Here we are, the male female graph. Okay, next thing that we'll take a look at, so that's just the client gender. Maybe now we want to look at by age. The kind of graph that we were interested in looking at was the outcome 1, we believe it's called. So you can always check, okay, it's outcome 1. Here we are. And let's now say outcome, pardon me, outcome 1 in the fill aesthetic. And we will see what we have for each. Okay, and we have, again, fatal, not resolved, and resolved. The interesting thing here, and that again, we can see some kind of neat data, is that most of these cases have been resolved. Okay, some have been fatal, okay, which is unfortunate, of course. But the idea of not resolved means there's no result yet, so they haven't had time to heal. So these are typically cases that are more recent. And if we look at where the distribution of cases are more recent, it tends to be in younger folks. Okay, so this is again ways that we can look into the data and learn from it. Okay, so this is where R becomes a little bit more helpful, is that when I save this file, okay, I can come back to it in weeks and know exactly what I did. I filtered this, I filtered that. So I can, if I want to screen clip this plot and present it or use it somewhere, I know exactly how I got it. Whereas if I were to go back to Excel and I were to say, okay, can we reproduce one of these plots, unless you wrote it down or remember exactly what you did, it's going to be a lot trickier to do that. Okay, so now we're going to look at some, so this is using the bar. Let's look at one way to create the exact same plot a different way. This is with a bar plot. We can also do this with a what's called a geom column plot, which is similar. So I'm going to consider the exact same data, rather than having to do things twice. I'm just going to go like that. Okay, copy it. I'm going to paste it. Okay, so now I'm dealing with none of the unknowns and only male and female. And then what I'm going to do is I'm going to do a command that will count everything, okay, for the cases that I'm interested in looking at. So to count in this particular case, we want to do is we want to say, okay, we want to look at each age group on its own. And once we have each age group, then we want to count by outcome 1 in this case. So let's go ahead and we're going to use this function called group by. Pretty handy. And we're going to group by specifically age group. And then once we've grouped by age group, we're going to use the count function and say, let's count the outcome 1s. Okay, and then it'll give us an output. And this output, we can see there's 17 more rows, but it says, okay, here's the fatal. So there's 1 not resolved. So it's the same chart that we would have seen with the pivot tables in Excel, except again, we filtered, we've grouped by. These are really intuitive. And then what we want to do is we want to say, okay, let's plot this again. We're going to take this chart that we would have here and we're going to plot it, okay, in such a way that X is equal to the age group. Okay, but this time we're going to have a y, and that y will equal n in this case. Okay, this output here is n. And so we're looking at age group, outcome, n. So we've taken this enormous data set, okay, and we've reduced it into these 17, so I guess 27 rows, 27 by 3 table. Okay, so let's add again a layer to this, and the plot we want to do this time is not a bar plot, it is a column plot. And we can see there are two types of bar. G on bar makes the height of the bar proportional to the number of cases. Okay, so this is where we haven't manipulated the data at all. And the column plot says, okay, we want to look specifically at something that we've already counted by weight. So in this case, n, and we want to use the same fill command here. And we want fill to be equal to outcome 1 in this case, which is what it's called here. And this should work. Perfect. Same plot, which is great to see.